Regular expressions, sometimes referred to as regex, provide powerful ways to search for and, if necessary, replace specific patterns of text in a file. This is the first of a pair of videos I'll use to introduce regular expressions. While these two videos are included in a playlist focused on command line computing, regular expressions aren't truly command line tools. Instead, they're a more general set of tools that are implemented in many pieces of software and languages you'll come across. But I'm including them here because they'll be used in command line commands we'll cover in the next few videos. Let's first talk about what regular expressions are. Simply, they're sequences of characters that are used as search terms to find specific text within a file. Those characters might be interpreted literally, or they might have more flexible meanings. For example, a wildcard that matches multiple characters. In an earlier video on globbing at command line, I referenced regular expressions to contrast them with globbing, and I'll do that one more time here, as it can be a point of confusion. Both globs and regular expressions can use wildcard characters to match patterns, but an important difference is that globbing only applies to file and directory names at command line, while regular expressions are applied to text within files, and like I mentioned earlier, regular expressions, unlike globs, are also implemented in many places outside of command line. So, that hopefully clarifies one common point of confusion related to regular expressions. Again, that globs and regular expressions aren't the same thing. But as we start to focus in specifically on regular expressions, there are a couple other places where confusion can arise. First, there are multiple types of regular expressions, sometimes referred to as flavors of regular expressions. The primary reason this matters in practice is that characters can sometimes be interpreted differently by different flavors of regular expressions. While there are quite a few types out there, the good news is that there are just a few that are widely used and that you'll likely encounter. These include POSIX basic regular expressions, POSIX extended regular expressions, and Perl regular expressions. In addition, there are several classes of metacharacters that include wildcards, quantifiers, and modifiers, and the way a specific character or set of characters gets interpreted can depend not only on the flavor of regular expression being used, but also on the context the characters occur in. So again, just to emphasize these 2 points, how a given character gets interpreted depends on 2 things: the flavor of regular expressions you're using and the context in which the characters appear. We can start to see both of these factors in the examples listed here for 2 types: POSIX extended regular expressions on the left and Perl regular expressions on the right. Let's say you're working with a program that implements the POSIX extended regular expressions. You could use the dot as a wildcard to represent any single character. Adding a quantifier after a character specifies the number of times that character has to occur for a successful match. So, a dot followed by a 3 inside curly brackets would match any 3 characters. There are also a number of modifiers. For example, capital A would match a capital A at the beginning of a line, but not a capital A anywhere else on a line. Now, notice that I've included the question mark under both the quantifier and modifier sections. This is one example of how the interpretation of a specific character can change based on its context. A question mark after a character acts as a quantifier, except if the character it follows is one of the quantifiers. In that case, it serves a different purpose, as a modifier that turns off greedy behavior, which is something we'll talk about in the next video, where we'll practice with some regular expressions. The last thing we'll cover in this video is the effect of the type or flavor of regular expression. All of the specific characters we just talked about were associated with POSIX extended regular expressions. So what if the program we were using used Perl regular expressions instead? Those are actually an extension of the POSIX regular expressions, meaning that all of these on the left side of the screen would still be available to you. But Perl regular expressions include a number of additional wildcard characters. For example, the \d combination can be used to match any digit, and using a capital D matches the opposite, anything that's not a digit. In contrast, under POSIX extended regular expressions, the \d combination wouldn't match a digit, since that wildcard isn't implemented in that flavor of regular expressions. Of course, there are still ways to match a digit under POSIX extended regular expressions. For example, including the range 0 to 9 inside of square brackets would have the same effect that the \d has in Perl regular expressions. It's just a few additional characters to type. Likewise, putting :digit: inside square brackets does the same thing within POSIX basic regular expressions. The important takeaways here are not really the specific meaning of any one meta character, but the more general properties and behaviors of regular expressions. That they are sets of characters that can be used as search terms to match text within a file, that characters can be interpreted either literally or as various types of meta characters, and that exactly how a meta character is interpreted can be dependent on both the type or flavor of regular expression being used and the context the character is in within the regular expression. We'll use the second video in this pair to take a look at some specific examples of applying regular expressions to a data file.